right. All right. Good morning, everybody. This is the first meeting of 2025. Happy New Year to everybody, and thank you for joining the meeting on those online and everybody that's here in person. We have two talks today. First one's gonna be Alan. There he is. And after that, Jim's gonna give us a talk on driverless taxis. Waymo. Yeah, Waymo. So that should be fun. Alan, want to take it away?
All right. Good morning, everyone. When I had the idea to introduce LangGraph, I was checking over our notes from the previous months, and I had that on the docket for November. But I think the way November played out was we kind of glossed over it. We took so much time on the previous topics that I'm just like, LangGraph is here, graphs and nodes, enjoy. So I'd really like to take this hour today to give you not only an introduction, but also to kind of share with you my excitement about what this tool is and what it does. I haven't been this giddy since a teenager, and it took me a minute to figure out why and what I was relating this to from my younger years. And then I remembered there were 3 books that I read cover to cover over and over again as a budding young roboticist, all by Heiserman, who we unfortunately lost in 2020. Prolific guy. The 3 main books were, and for the other graybeards in the audience, these probably look familiar to you as well. How to Design and Build Your Own Custom Robot. It provided a roadmap for op-amps and amplifiers and motors and gears. It kind of laid out all of the individual areas that you need to master more or less in order to build a robot. The second one was, and I wanted to do this one so bad, Build Your Own Working Robot. He talks about co-opting a, call it a mobile platform, little child's motor car with a battery to build Buster with a photo sensor, and it's 100% solid state, no computer in it for, light avoidance, like going to a super, super cool project at the time. We're talking 1979 was when this was published. So when I was reminiscing and thinking of all the things, we've got, these are scans from the book, right? So he co-opted this children's toy, added in a gear motor to replace the steering wheel and a little rack for some circuit boards. And you had at the time, a state-of-the-art robot. Would be even fun to build today. But the one that really got my gears turning was how to build your own self-programming robot. I wanted to do this so bad. It was a rack mount 8085 with flip switches and lights to program. So you're talking way back in the day. You set your address, you set your data, you hit commit, there's a read and a write button. And what was really cool about this project, which was cutting edge at the time, was he had 3 modes of operation, if you guys remember this. There was alpha, beta, gamma. Alpha was you spent hours programming in a set of behaviors or actions, and you hit run and it would drive forward, drive back, etc. Right? And then his second level was beta. And I'm paraphrasing a bit, but beta would have some crude memory of its surroundings or some actions that it could then leverage as it goes through your program. And then gamma was a forward thinking, maybe a little bit wishful thinking, but it took that to the next level by deciding actions based on the rudimentary memory that it had, right? And so you build all this. I didn't have the wherewithal to do it, so I just read through it cover to cover a couple of times. You had these 3 levels of behaviors with an 8085 processor that you could, in theory, with the wherewithal, money, and soldering, build in there. So this dominated my young adulthood. And it took me a minute to understand kind of the parallels to it. And so there's an article here with the Rodney robot with the battery and the 8085 and the switch panel. This coolest thing since sliced bread. So let me install this a little bit. So I wanted to draw some parallels here to kind of share the parallels that I see and why I'm so excited about this. Let me go ahead and we'll do 2 tabs here. I was going to attempt this in whiteboard or and I'm like, oh no, actually this meme fits perfectly. Wait, where did it go? Oh, there we go. Paste. So from my childhood, you had Buster the robot, right? Yeah, Buster the robot. And then on Rodney, you had the alpha writing code to get it to do something. And then beta, it would take rudimentary memories to direct the code. And then the omega, the gamma was, it could take steps related to it, almost like, he called it self-programming, but it wasn't quite that.
Did it
kind of
count,
AI,
was it
right?
like adjusting probabilities, gamma? Like probability of some sub-program or?
I didn't have the time to reread the chapter before
Okay.
the meeting, but so I'm paraphrasing a little bit. And actually, the whole book is available online through Open
Well, I have the
Library.
book.
Yeah, I think I might have it as well. I have 2 of the 3 at home.
And I
as
have
well.
all the books you've talked about so far.
Yeah, it's I would imagine for many of us, they were required reading. Like it was the go-to, right?
But my favorite was the book Android Design.
Ooh, I'm gonna have to look that one up later.
I've heard of that one.
Okay. So this was my childhood and making my brain explode. But check this out. I see a similar trajectory with large language models and agents. Now they're all over the news right now. If you're following the industry, 2025 is the year of the agents. Every kid with half an idea spools up a startup and gets VC funding and is a millionaire by the end of the year. It's that hot right now. And it's very easy to assume that this is a bubble, but actually it's not. You may have heard towards the end of last year that we had hit a plateau in terms of smartening up these large language models. Oh, OpenAI is disappointed. They're not getting the commensurate increase in results from training their larger model, or Google or Anthropic. And so it made the news, all the doomsayers. We've hit peak AI. It's all down here from there. It's another bubble. But that's not what's happening at all. What we're seeing is that the agents don't actually have to be as smart as we're trying to make them. We can add them into a framework that we talked about in December, prompt engineering or chaining, setting up the problem in a way that we can leverage all the strengths of these language models to accomplish some task, right? And that's where the magic is. It might have been even 10 years ago. 10 years ago, Thomas and I gave a talk about AI to some private college. And the point that I was making at the time, might have been 12 years, I don't know, I'm getting old, was that there was a fork in the road this time. And this was just after GPU became a thing, where machine language researchers discovered that they could co-opt the shader programming on a graphics card to simulate neural networks and neuron firing faster than you could run it on your computer, right? And we had run to the limits of expert systems and hard-coded Python and databases for smarts. And so the fork in the road was, it looks like the GPU, the neural approaches were promising. And so that was one of the points of my talk. Now, since then, over the past 3 years, seems obvious now. But what's happening in the current generation, to kind of close the loop on one of my third favorite meme here, is we started off with large language models. They started out getting the gist of English, and after we fine-tuned them to be helpful, they turned into chatbots. And you can get a free account at chat.openai.com. You can run these locally. They have a little safety baked in, but that's kind of our starting point, right? That's our building block. We have let's just call it a chatbot. That's fine. We have a chatbot that can answer questions and seems to have some compressed knowledge of the world that we impressed into it during training. I keep grabbing the wrong mouse. After that, we have, I'm going to call it LangChain, just because that's the tool I'm most familiar with. But LangChain provided an abstraction. Now, all of this is in Python, right? And you can code your own frameworks. You don't have to use any of this. But what LangChain did is it made it easier to use a large language model in some process with a beginning and an end. And it exposes the language model in a way to make that easier. We can call it a rigid chain, but a series of steps like code that you write to accomplish some task or some goal, where the language model is a black box, but it can do things because of its smarts that you just couldn't code for, right? So that's the LangChain level, the next one up. After that, what we're going to give you wrong mouse, an introduction to today is the tool that I'm going to show you is LangGraph. All these are open source, and again, based on Python. And it provides a series of abstractions that, leveraging everything we learned over the past year about chains of actions, let's put the language model in control. Let's get the language model to generate the steps, and then route the steps based on its knowledge of the task and the steps to complete. And this is super scary for people who are used to writing code. You want to set them up, engineer the prompt. I'm stretching a little bit. You want to set up the language model to be able to accomplish this task. You give it tools, and then it decides how it goes about it, right? Super scary, super exciting. And while this framework, now we're seeing a meld of traditional Python programming with large language models. So that fork in the road that I talked about earlier, they're intertwining again, right? So we're setting it up to accomplish some tasks. And while all this is happening, you have a whole bunch of smart data scientists and people working on the architecture of large language models, as well as training newer large language models and fine-tuning newer large language models to give them tens of thousands of examples of being helpful in this type of a framework, right? So you have these two things running in parallel. So that's kind of where we are at the third step. Now, this LangGraph, the language model has the ability to decide its route and to execute on those steps, and that's going to be happening everywhere in 2025 and on. There's a handful of different frameworks. LangGraph is just the one I'm a little bit more familiar with, but they all accomplish about the same thing, to abstract away these concepts based on what they know you need to do, and then you can use these tools to kind of piece them together. And so I'm already super jazzed about this. This last square, I don't know exactly what this is yet, but I'll share with you some things that I think it has in it. Today, at our current job, we're experimenting with agents that write and execute their own Python code. We're experimenting with agents that write and execute SQL queries to pull database, inquire database, find patterns in database data, update rows, create entirely new tables. These are some tools that are available today right now. So with our current trajectory of chaining, using Python in a chain sequence of events to accomplish some task, and in LangGraph, putting the language model in control of directing the route it goes to accomplish some goal, and knowing that already they can write Python code, they can write SQL code, they can write their own code. I think the next step, maybe not the last, and this is all arbitrary, right? So as the discipline, evolves, we may compress these down a little bit. But that last graph, what's gonna happen next is very exciting because I see the language model writing and testing its own code and its own routes, all in Python. And I can't wait to see what this framework and what the capabilities of the next one are going to be as we get comfortable with the language model directed graphs. What's gonna show up in this square, maybe even this year or next year.
Wouldn't that be the singularity in that next square?
Yeah.
No, no, really, I mean, so the idea is you have self-improving AI, right? And that's what you're saying, and that's kind of like the singularity self-improving.
Right, it can learn on its own would be kind of the next one,
It
right?
teaches
And
itself.
Teaching itself and self-modifying code, basically, kind
Yeah.
of like the book, you know.
Yep, and
Strive.
I came across a YouTube clip, and that's actually a really good point. We're gonna do a placeholder with that. And there was a guy talking about a paper. I started reading through the paper, and it was a little bit dry compared to the what he was extracting from it. But it was basically two adversarial models that were, one model was teaching itself to solve math problems, and the other model was critiquing it. And it ended up getting O1 level performance with a 7 billion parameter model. And he was looking way ahead into our last square about once you get into that self-improving loop. And one of the things my boss told me when I first hired in is it doesn't have to be fast in the beginning, it just has to work, right? From tangent upon tangent, almost everyone that's using these large language models today, it's an interaction. You type something and you get something back out, right? ChatGPT, a lot of the workflows. There is no reason that future steps in here, up including LangGraph, it'll get a little bit more expensive if you let it run on OpenAI, but you can run these models locally. I mean, Brian just this week is working with 5.4, 14 billion parameter model. You know, your computer sits idle 20 hours of the day. This year, we should be able to see, and where I'm hoping to impart to you, the tools that I'm showing you today are free to download and run locally on any computer or laptop. They do run a lot faster if you want to run them locally with, an RTX graphics card. But up until we let it churn overnight, it costs a couple of bucks for an OpenAI API account to be able to run things off of there. But much like my childhood and the Buster and the Rodney, these things being within reach, if you just have a soldering iron and spend some bucks on the car and some aluminum extrusion, you can play with all these things today, the literal building blocks of artificial general intelligence. And whereas the promise of a gamma level intelligence in an 8085 Rodney robot were a little bit of a stretch, this is the real deal. And my takeaway from my introduction this morning is to get you excited about it, to be able to contextualize and frame what the tool does and how it works, and give you a quick low code. I mean, everything's Python code, but we're not going to focus on the code. We're going to focus on the components to show you how this fits together. And at the end, if there's interest, we can make this into a series and further delve into it, because this doesn't solve the physical intelligence problem of a robot picking up something. But just like your brain has different parts that are good for different things, this is the thinking part of your brain. So this is the part that has a connection to vision, that knows that, there's a glass on the table. And this is the part of the brain that can be task oriented with, oh, dirty dishes go in the sink, right? This is the framework of what's going to be your real intelligent robot brain. And that's what gets me super excited. And I'm happy to share things that we've picked up. And hopefully if some of this spills off onto you, we'll be able to talk more about it next month.
Oh, thank you.
Do you agree that if this were incorporated into a mobile, arm and hand, autonomous machine,
Yeah.
then somehow this complex software would have to become philosophically grounded in physical reality. That's gonna be the hard part.
Yeah, and there are people working on that right now. That was actually one of the main points of NVIDIA's keynote earlier this week at CES. And whether or not the 10th Ultimate robot brain exists as a separate large language model entity from the physical one, we're not sure. We're gonna try them both out. But there are people working today on applying this neural net deep learning technology to physical robotics with promising results. Is it figure one? Figure one almost as a joke, strung together a training set based on videos of people making coffee. I'm sure there was something in there that extracted skeletal positions. And they're like, hey, if we just throw this problem at this technology to see if we can train a robot to make coffee, right? Impossible just writing code, well, reliably, repeatedly. And it worked. And that kicked off what you're seeing in the background.
When you said it worked, in what sense? A physical machine mode or a simulation?
Yep.
Which one?
By watching videos of making coffee, they're able to train a model that allowed their physical robot to put I think it was a cup and a Keurig and a cup and a coffee maker and click through and grab the coffee cup out.
It's very good.
It was executed almost as a joke, but then that illuminated a whole new area of research that went from that can't possibly work to everyone's on it now. So now you're seeing the group framework and the NEMO framework on NVIDIA, Mujoko on the Google side that are setting up the pinnings, the groundwork for training not language models, but physical models to control real world robots in the real world.
I see.
Yeah.
Is that considered unsupervised reinforcement, or it's not reinforcement?
It is reinforcement
It's
learning.
reinforcement learning, sort of unsupervised, because it's just, here's the videos of people making coffee, and
That's.
or is that is
was
supervised. Unsupervised is
Well,
like
yeah,
you
because
can
you still-
pick any video.
And actually, a reinforcement learning generally has a goal function. For this specific example, I'm not sure. I don't know.
It sounds like it's supervised, right? Because you're giving it only
You're
videos
trying to
of,
predict the movement of the person making coffee, probably.
right, you're giving videos of a person making coffee.
But there's another one, Joe, about like the real world and everything. And NVIDIA is real big on their simulators and Omniverse and all that stuff. And these self-driving cars, the Teslas and stuff, they just go back and forth between the simulator and the AI that learns and back and forth. And it is learning the real world.
Because it's got real data from the real world.
I think that's the sleeper, AI technology, because we talk about the LLMs a lot, but the reinforcement learning,
Yeah.
Yeah.
like took robotics classes like 30, 40 years ago, and it was, we were talking about it, but the simulators didn't work that well, the physical models didn't work that well, but it seems like they're getting there, and I'm seeing more and more reinforcement learning. So it's this other AI technology, and it deals with the physical world, and it works. So that's gonna move fast.
I move fast because they do it, thousands or millions of virtual robots
Yeah.
in the virtual environment, practicing and with real, learning how to walk, learning how to move, all that.
So you can extend this diagram to this first box where you had large language models, if you say foundational models. Now you've got video models, image models, physical models, language models. Now you've got the scope for AGI.
It's multimodal. You've got all those different.
But it's the same idea, like the large language models is a way of saying like all these basic models they know everything.
Yeah,
vision
and the moment they get, the
sound.
second they get self-improving, that's where we have the real takeoff. We're already on
Yeah.
this.
We're on an
Logarithmic
exponential
trajectory, yeah.
movement.
Yeah.
But self-improving that, you have to work out the kinks in the current stuff before you get there, because if the system has to be constantly corrected by humans, or it's making mistakes and it can't self-improve or will yet reliably, because it will, it may go off in the wrong direction and self-destruct,
Yeah, and that's where I like the current language models, I like to characterize it like this. I try to anthropomorphize everything because, well, we're robot people. The knowledge and intelligence of a PhD graduate with the common sense of a 10-year-old. I kind of think that's where we're at right now.
Yeah,
Maybe
yeah,
it's
good show.
right? And every generation of, as we discover new areas where we shine light on an area that it sucks at, we close that gap, and look how long it took us to close the gap on how many R's in strawberry. That was, what, 4 weeks? Right?
Right.
It is, okay, well, it's more of a novelty. I don't know how important it is to be able to spell, but, but they did that. So, yeah, it's,
By many engineers.
the area is moving super fast. Okay, so with, all of that laying the groundwork, very long-winded, here's why I'm excited. Hopefully you're excited too. Lang chain is something we talked about a lot last year, chaining together a series of actions to accomplish some goal. The graphs aren't really as interesting on this one, and I'll start pasting in some links here for anyone who wants to follow along. The fun toy right now, and there's about a dozen frameworks. If you find a different framework that resonates with you, they all accomplish about the same thing. I like LangGraph, I like the LangGraph guys. They publish YouTube videos all the time talking about new applications. And the first thing they'll tell you is to not get hung up on any particular framework, understand what problems they're trying to solve and how they're solving it. And don't be afraid to fork components to make them do your bidding. It forms a framework of understanding, and then learn from it and do cool stuff. Let's see, pick on any one of these here, I think. So we had already talked about LangGraph, giving the agent the ability to decide what route it takes based on the tools it has access to and its understanding of the task at hand to run some goal. So instrumentation is a lot more important. They have a tool called LangSmith that you can use to like look at the log, like when you get the answer, like how did the language model get there? The basis of this is you've got 3 basic components. Sorry, these may not be in order. I'm trying to do this in a way that makes this
1, 2, 3.
there we go. Maybe we'll start here. So much like the name LangGraph suggests, it's a graph. It's a graph. You've got entities called nodes that are connected by lines called edges. So going back over to like this guy, find, see if we can find, let's just pick on this guy. So I'm just trying to pull up something that we can use as a visual aid. So in a graph, which you can represent visually, there's some tools to do that. All the graphs have a start and an end condition, right? You got to start somewhere, you got to end it. And in a graph, you have a series of nodes. Generally speaking, these nodes are little self-contained LLM programs that accomplish some task. So in this random picture I just pulled up, there's a researcher node, and then there's a researcher router node that, based on the task at hand, will route the program flow, in air quotes, to one or more different other nodes. And so large language model in the background is in charge of making those decisions, and each node is a unit of work. And these lines that connect your different nodes, so just like in ROS or in an graph, they're called edges. And the edges can be absolute edges. Once I'm done here, I go over to here. Or they could be conditional edges, where depending on your state, it might route to one node or another, right? So you can already see like the excitement and the trepidation of handing the reins off to your program. So we've gone from writing the entire program beginning to end in LangChain to writing out all the components and smartening up just enough Python code to tie it together so the large language model understands what it needs to do, the tools at hand, and the proper sequence of events. And then like, go, do something cool. And then it accomplishes that.
One quick question.
Yeah.
Is this a diagram of an augmented transition network?
I don't know how to answer that question. Can you help me understand what an augmented transition network is?
Well, some of the early work in natural language understanding used augmented transition networks, and this looks remarkably like diagrams that I've seen in some really old books from like the early 1960s. So that's why, and they called it an augmented transition network.
And I think you also call it a state machine, right?
No, it's fancier than that.
Fancier, okay.
Okay, yeah,
Are
Mike.
these all executing simultaneously, or are they executing only after it transitions through an edge?
So there are two ways of setting it up.
Yeah.
In 2024 parlance, generally these things run sequentially. But the LangGraph framework supports asynchronous calls, parallel calls. As a very simple matter, maybe you're collecting information for a research paper. It's a very common hello world for LangGraph, right? So, you need to do a Google search, you need to evaluate the summary, and then based on the summary, you want to pull in the text of the web page and then summarize it, right? So if I were doing this, I would go to web page number 1, read, looks good, browse, summarize. And this is a very simple example. There's no reason why your agent couldn't spawn off 3 different threads, identify the 3 different articles, and then spawn 3 different threads of execution that each grab the summary and summarize it and bring it back. That's scatter gathered kind of a thing, and everything in between. The sky's the limit based on how many GPUs you have running locally or how deep your wallet is when running out of OpenAI.
Well, with today's super high-speed computers and awesome amounts of memory, it seems like you could have a number of these all executing, whether they actually have anything important to do or not. They can continue to compute whatever data they had and still communicate with each other by these diagram edges. That's kind of where I was coming from.
Yeah, you could do that. And then to get back to, to an earlier point, in ChatGPT request response things, you want things quick. Some things I'll give the answer to. Like maybe I'm wondering what's going on today with, AI research papers on RSSC, right? Like I don't necessarily expect that right now. How cool it would be to set up one of these things to go in the background, look at all the papers published over the past week, go through the summaries, identify patterns. Like that can take an hour or whatever, right? Like super, super powerful stuff here.
I'm thinking in terms, an analogy with the human brain. What I've been able to determine based upon what's published, the human brain doesn't really have separate physical volumes in it that just shut down completely, waiting for something else to happen. It's pretty much each section of it is computing something all the time.
Yep, and
So my analogy is where I came up with that idea that I just described about this.
okay.
Well, the human brain does have quiet moments when the neurotransmitters are inhibited, right? There's
Well,
like,
yeah, there are drugs for that,
well, you can, meditation works too. I mean,
But
that's what-
even when you think that you're
Buddhist
not doing
people-
anything with your brain, like you're asleep, if somebody pulls open your eyelid, your eyes sometimes are moving around.
yeah, REM or
Yeah.
REM sleep. But yeah, I mean, right.
Yeah, unless they're fixed and dilated, in which case you got bigger problems.
Yeah.
Yeah, Mike.
Well, just talking about the brain and shutting down. My mom just had hip surgery and I learned that, when they put you under anesthesia, they turn your brain off. And then there's somebody there that's responsible for keeping you alive. So I think they completely turn off your brain. So, but anyway, I had a question about, not really a question, but it seems that if you throw a problem or a task at something like this, if you do it 2, 3, 4 times, you might get different results each time. So there's 100 ways to skin a cat. I'm just wondering kind of how it decides on a specific solution.
Yep, and that's something, so, we're gonna end this talk this morning with a very simple example to give you a familiarity with the basics. And if there's an appetite from the club, I'm happy to continue this series as we expand on it and add additional capabilities. Memory is a really big thing. So tangential to what so when people learn, and I'm guessing when these guys learn as well, you come up with a game plan and you execute it. And some game plans end up in success, some game plans end up in failure, right? For the ones that end up in success, that can be a memory, right? So you need someplace, hey, I needed to do this, and these are the steps to it. You need to have some place to tuck that away. And so,
But you also have to remember, like, oh, I tried this once and it didn't work.
yeah, perhaps, right? Even to store the failures, right? So there's a couple of different things, like getting really hand wavy, right? Like when you're talking about building an intelligent robot system with pieces that we seem to have today, it seems like instead of getting into the fine tuning and stuff, like to have some type of a database or RAG or Chroma based memory store to put this stuff that can then be consulted when you're faced with a similar task in the future, right? Like once you figure out how to do it, knowledge earned is knowledge learned for people as well as agents it should be. And then just to be able to stuff that stuff out to one side, or if you're using a commercial bot. So like the Tesla model where you have 1 million of their robots all out doing their thing as things are learned and report back to the mothership, or I guess the main plot point of the AI movie with Will Smith. As those things are learned, all the robots can take advantage of them, right? So there's all kinds of interesting futures where this becomes the fundamental component in something far greater, gestalt, right?
Yeah.
All right. So hopefully you guys are all as excited as I am. Getting back over to our 3 types. So we talked about nodes. Nodes are our action pieces, our edges, our little programming concepts that connect one node to the other. And the last one is state. So you could think of this as your short-term or working memory, right? So you need a cubbyhole, someplace to store what you're working on, what the game plan is, and how far along you are, right? So in a chatbot, maybe your state is just your conversation history, everything we've talked about up to that point, right? And that forms the context of the conversation and is then made available to the language model for follow-up things like, hey, statement number 1, my name is Alan. That's great. The language model, that neural network does not know that, right? It's a fixed point in time and space. But if that becomes part of the conversation history and that conversation history is shared with the language model for every iteration, it becomes part of the working memory. So in the follow-up question, this is where we're going to end. When we get through I promise to not, bring us over to code, is you can then ask a follow-up question. What is my name? Because the context of that conversation was passed to the language model. It's like, oh, your name's Alan, right? So your conversation history for a chatbot is kind of the state. And if you're solving a problem, the state is something that you define. So if there's an example for writing a research paper. So for that agent, the state is what is the current input from the user is one portion of the state, and another portion of the state is your conversation history. And the third portion of the state is a construct with each of your steps and where you are in it, right? You have total control over that. So you have 3 pieces, just for now. And then when you expand, if you have a database connector for all your successes and failures, that could be some element of state if you're connected to a database, right? So you could, whatever you need to solve the problem. And as we wrap up this morning's talk, our state is just the conversation history. Super, super simple. All right, keep grabbing the wrong mouse.
We also refer to that as seen in papers as the tape, the old concept of
The
Turing machine tape, right? Yeah, they said you add the tape recording to the large language model, and now you have the record of what's happening, just like we already seen with the chain of thought. It has all of that information that is being stored, just like a human writes down things on paper, because we can't have more than 7 things in our, I can't remember 7 numbers, more than 7 numbers for more than 5 minutes,
That's one of the problems we're working on right now, because you only have so much context when you call the LLM, right? So that's like your working memory in your brain, your short-term memory. So what do you put there and what do you put where it's accessible, like where you have to think about it to grab the fact?
It's almost like a cache, like
Yeah.
a close cache to the CPU.
And getting that just right is.
Oh,
the
it's
trick.
it's a give and take.
Time is money and context is money and,
Mhm.
Right, it's all,
it's all a balancing act.
and it's, yeah, and
And
it's,
it changes, like, there's new advancements made every day.
right, and they're taking over nuclear power plants to, power this AI. So we wanna conserve energy. It's gonna be a big factor in conserving energy by adjusting the AI.
Yeah.
Computing.
Yeah,
Well, that's another
We
issue.
use less energy.
Yeah, yeah. On a side note, did you see that it was, I think Stephen Colbert, the Late Show with Stephen Colbert mentioned quantum computing at the beginning. He was like, researchers just reported that, a quantum computer solved a problem that would take our best computer 4 quintillion years to solve.
That was the Google
In a
Willow.
half hour.
Yeah.
I'm like, I'll have to check on that. But yeah,
yeah, and then.
it's very narrow right now, but.
It is, and they're affording greater capabilities to, there's a whole area called small language models now, right? So when I can't remember, I might have been chatting up with Brian later this week, when I spec'd out my deep learning computer that was being used for mining until the bottom dropped out, I'm like, okay, so there's 4 24 gigabyte cards, so I could do a maximum of a 96 gigabyte model. And it's based on the trajectory of how things were working, what was this, 3 or 4 years ago?
Yeah.
And I'm like, okay, well, maybe that would be big enough to do something interesting, but it was a guess, right? And when we were doing like the 22 billion parameter model, I could barely fit it in. It had never, in a million years, I would have never guessed that they could make smaller models so performant that I could spec out 6 different models on those 4 cards to run them simultaneously. Never would have guessed that they could have, because we were playing with 7 billion parameter models and they couldn't even list a top 10 of anything. They would lose count, right? And now
They would repeat themselves.
7 billion parameter models and 4.5 gigabytes, right? In 4-bit, it has a lossy compressed knowledge of everything available on the internet for training, right? Like, and they hallucinate, they're not always right, but the example where like, what's first line for deworming for cats to tell me about black holes and it's got real knowledge that it didn't have, 7 billion problem didn't have, and it's nuts. It is absolutely crazy. So
That's because of advances in training and.
in training and fine tuning, right? So
Fine-tuning.
synthetic data and using large language models to generate synthetic data to train and as greater demands are placed on them, the fine tuning corpus has changed so they can use tools and anyways, yeah, all kinds of stuff. So before we get into the high level code, and I promise not to drain the code, is you can run these today on your desktop or laptop with an OpenAI account and just spend a couple of bucks on inference, right? $10 will get you a long ways on most of the models, but there is a cost outlay. If you have an RTX graphics card and you can run these locally, then you already have everything you need. And the cherry on top for that is that you can use different language models for different functions. So just going back to this random chart here, perhaps the call tool node can be served just fine by a 3 billion parameter model running locally. So you do that. It's super fast. It's on-prem. It's free for you, and you're good to go. The router maybe as well. It can be handled with a 3 billion parameter model. Now, it may turn out that your researcher node, it needs the most smarts of it. So maybe that's the one that you wire up to OpenAI 01, right? For the final, just based on the task at hand, you basically, you throw the minimum amount of horsepower that you can get away with to get reliable results out of each step. So you can have a heterogeneous implementation of an agent with different large language models in the back end to save money. I mean, you could run them all off 01 if you wanted to, but it's a lot cheaper and faster to use smaller models for the things that don't need that much horsepower. You can totally do that. So again, super exciting to be able to, all these things are open source, they're well documented. The LangGraph guys post YouTube videos all the time showing how to use their tools. And this is the underpinning of artificial general intelligence, whether it's on your computer or in a robot. So just think back to being a kid and reading the Eiserman book about self-programming a robot and realize this is happening right now, but for reals. Okay.
But Alan,
Yeah.
a human has to come up with this graph, like these different, functional, activities, right? Like be a researcher, you have to say, I want to, do research on papers and make a graph or so and there's a potentially infinite number of these
Yes,
graphs that
They are-
to create AGI.
they
right?
they are still task oriented for now.
Okay, but that may
Until-
change, yeah.
Yeah.
So
Right.
then eventually you may be able to say, to ask for anything, go, order me some pizza and then, work on my finances and figure out how much I can spend the next year on whatever. And then it figures out those steps.
This is really nice because I can constrain it to a problem, right? I can say, hey, you're doing research papers and it stays constrained on it. But it's not a big leap in this last box, right? So it's not a big leap to have a graph writer agent,
Exactly.
and you're done, right? You've done everything.
That one may have to require a lot of work to get it good.
Yeah, fine.
Yeah.
But I mean, it's not a big leap, right? Because they already write programs. Why couldn't
Right.
they write a graph?
Write a graph.
There's enough examples, right?
Yeah.
That's what.
Yeah, to get to Michael's
Yeah.
point, if you figured out how to do it, you stuffed that in somewhere. In that architecture where you have like a brain agent and its only job is to look for previous successful patterns to structure graphs to accomplish that goal. And it's just like a person sitting down, whether it's subconscious or conscious, of like, crap, how am I gonna do this, right?
Yeah, well, in fact, I guess I should already know this because the previous research like that, do what I say, not what, do what you can, not what I say. That whole, the Google and the, RP1, that research, it already takes a high level command and breaks it down into steps. This is just another more advanced version of that.
And it went from impossible to in reach. In this arbitrary breakdown of progression, that's what happens next. We've already seen the components work today. So as a whole bunch of super smart people get comfortable with this level of tooling, that will inform the next steps necessary to get even closer, right? So we didn't understand the power of the LangGraph mode until we got comfort with LangChain.
Mm.
And so as we get comfortable with self-directed nodes, yeah, we're gonna see a lot of activity this year. Yeah. Okay, so we only have a few minutes left. That's okay because I promised not to focus on source code. So what you're gonna see here and then I just pull up
Otherwise, I can't do anything. Enjoy the source code while we can, please.
That's right.
We're gonna be out of a job. In fact, I'm a manager now, so I guess that's fine, it's okay. Until the AI catches up.
Never say the AI can't do that.
No, I'm not gonna say, but
Yeah,
it can't handle people as well right now.
yeah.
That's a whole other.
All right, and I'm not gonna talk about what's in the code, but each block represents a different step to get a hello world model example. So the last link that I posted in chat is straight from their website, which is their quick start. And if this excites you as much as it does for me, I would, get it installed and I would go through here top to bottom because they break out exactly how to add features into a LangGraph agent that are the exact features that you need if you're going to be doing something useful and at least interesting with the framework. So we're basically gonna really quickly run through the basic chatbot, and then I moved ahead to adding some conversational memory to it. And again, the code is all here. But conceptually, after we get the packages installed, we, hopefully my boss doesn't notice that I'm borrowing an Aviva
Yeah,
OpenAI
I
connector
noticed.
for a bit. We're just doing some setup in this, with the OpenAI API that I have access to right now. This is all boilerplate. And this is just some boilerplate code that talks about how to connect to the OpenAI API and to pass along enough information to authenticate. That's all this is. Now, the next step is we talked about graph state, right? What is your working memory for the task? For now, in our chatbot, our working memory is just a list of interactions. So it's extremely simple. So we have a state defined, it's a type dict with list and add messages. And so we have some boilerplate that says that our state graph is an object called state, right? So this is where you can have the most fun, because if you're doing something more advanced, like writing a research paper, right? You'll have some additional elements in your class to help capture that. So this is your agent's working memory to know what we're tasked to do, where we're at, and what's left. And I'm leaving it vague because this is something that'll be application specific based on the problem you're trying to solve. Now, there's a little bit of stuff in here for a memory checkpointer. There's some stuff baked into LangGraph that allows you to keep track of your, your conversation and your conversation history. And just as we talked about on the graph, this is all boilerplate still. So all graphs have a beginning and an end. The beginning is called start. And really, this in any graph code you write, it'll just be graph builder at edge. For our hello world example, our only node is a chatbot mode. So every time the chatbot node is called, it calls the LLM with a message, it gets a response, repeat as necessary. So we have a little boilerplate here, add node, we're calling it chatbot, and it's the chatbot function. And then every graph also has an end, so this boilerplate will appear in all of your graphs. We add an edge that connects chatbot to end, and we're good to go. So we have an add edge from start to chatbot. We have our chatbot as a node, and then we add our edge that connects chatbot to our end. So this is super, super simple. It's 100% documented in the introduction. That was the last link that I sent. And then after that, there's a small compile step that writes some Python code that ties everything together. And this example is straight from that tutorial again. And it results in popping up an input window. It passes your input to and the conversation history to the OpenAI LLM. It gets it back, and then rinse and repeat. Anything you type in, it'll pass to the language model. If you type in quit, exit, or queue, it exit out. And if you don't type anything, it sends its default thing, right? I was up later than I'd like to admit, trying to get the Gradio portion up as a last minute Larry thing, and I was getting frustrated, so we'll have to save that for next month. So Jupyter Labs allows you to run each cell separately. We're just going to do a restart.
Oh, you were trying to do radio, like a nice.
Yeah, we're going to save that for next month.
That's okay.
For the freeze, yeah.
That-
And so we'll just run it. And there's two things I want to do. We're going to run it. And I am also going to show you. Sorry. Let me get out of this for a second. Oh, with a minute to spare. Okay. Get rid of that. So LangGraph text, new command file it. So we,
Oh, can visualize.
oh, it's Python. Okay, we'll just move to this one for a second. So. And so if you were to pull this open in the visualizer,
Hey, nice.
you would see, so there's our hard-coded start and end edge, our chatbot node, and the two edges that define the relationship between it, right? Hence the name LangGraph. It's a graph connecting nodes and edges to encompass them. All right, so let's go back and we'll run all again. And let's scroll down to the bottom. I'm so sorry, Jim. I'm giving you a quick minute.
That's all right.
There we go.
We should still give people 5 minutes.
Oh, that's right. Oh my gosh, I'm so sorry. I sucked up the whole, sorry about that. Okay. Hello there. My name is Alan.
This is
45 minutes.
Yeah, sorry about that.
We can talk about shooting.
Yeah.
Stretch our legs.
Yeah,
Unless you want to know.
supposed to be end of.
Yeah, no, I'm so sorry. I totally forgot. I got too excited.
Yeah.
And because we're maintaining memory and conversation history, it knows your name is Alan, help me help you today, right? So, again, I didn't want to bury you with code. This is a very simple application of the tutorials that we were talking about
But does
before.
this automatically, it keeps a record of everything, is that included in that little bit of code where it's keeping, whoa, it's keeping all the messages?
The messages.
Yeah, yeah.
There's a tape of the messages.
So
Yeah.
even if you close it all the way out and like go in the next day?
No,
Not
That's
as
not
this
writing
simple
persistence.
example,
Oh,
but
okay.
that's a feature that's very easy to bake in,
Mm.
if it's important to you.
but this
So-
one's doing it by just keeping it in the type dictionary, right? That's for all of those messages.
Well, one of the things I'm wondering about on this, like the branching, do you have a start and an end node? In your current one here, is there any way to get to the end node, or is this an infinite loop?
This one
You hit quit. you type quit.
reinstantiates the graph for every interaction.
Okay.
Yeah,
Oh,
so it,
Oh, so it's a one pass down, one pass down, I got it.
yeah,
So
yeah.
until you quit it, it'll keep doing it.
it's
Yeah.
recreating the graph each time, isn't it?
But with the stateful messages.
And then it's passing the state back in for everyone. Yeah, so this is
Oh,
the
so it
simplest
holds
of
the state.
example. Yeah,
But you could have a graph that doesn't end, for a long time, right? Like
correct.
that,
That's the goal, right? That's the power of it.
or is in most cases, like if, for the research one, for instance, look up papers on LangGraph, okay, is that, it'll do its thing and then end at an end and give you the results.
Mhm.
Okay,
Yeah.
so there's no need to stay in that thing. You can just rerun it.
Yeah, that's a fire and forget, let it do the thing. So it's a more advanced one. This is just the simplest example to show you how all the pieces come together. It's kind of like a hello world example for a LangGraph.
But even most even fairly complex ones are just single shot, and but maybe you save the state and pass it in again. Right, you can do that. You can easily, like in this one, it holds that state and sends it through again when you do the next message.
Yep, yep.
Yeah, it's-
So again, I'm so sorry we went super over. I had totally forgotten about the 45-minute thing, but hopefully you share my passion for it. Go forth and create agents, and if there's appetite for it, we'll continue the series next month with by adding in more features. All right, thank you.
So,
Can you especially kind of add more tabs to my browser? Too many now with AI.
so while we wait for Jim, any questions for Alan?
I have a question. You said this was open source software, but on the last website, it still showed products and pricing. What is it that they want you to buy for LangGraph?
There's nothing for sale for LangGraph.
I thought I saw products and pricing.
It's free while it's in beta, and then eventually it sounds like they are gonna charge.
Oh, for LangGraph? No,
When it's set on the player price page.
yeah, LangGraph's open source. There's a LangSmith.
I don't know, what you just had up, it said.
All right, oh, here, okay, so they offer, their LangSmith instrumentation is free for right now. And they have a LangGraph server platform that they'll host stuff on. The pricing's for that. But yeah, the LangSmith and LangGraph are all open source, open license.
All right, Jim, you're up.
So mine has a few videos, so we should we'll get going quickly here and
Okay.
so, we can, see the content, or too much time goes by. Let me bring up my, oh yeah, oh, I write, there's that book again. I posted in the, chat about the, gamma. Basically, it said it adds on to the ability to learn a little bit from it, as well as having memory and apply to novel situations. So my talk is going to be about my experience taking a Waymo driverless car in San Francisco. And first we'll start out with, we're going to start out with an introduction video of the Waymo. Let me try to share correctly. Oh, look, this is a bug I noticed. Or you can't see it. There's a, oh, somehow maybe it's not a bug. It won't let me select optimize the video clip.
Really? I had it.
It's grayed out. This thing, yeah, I did it at home and it worked, but that's grayed out. I wonder why that will be. Let's see how it comes along.
So much emerging technology is just a show, so one can be forgiven for not being able to distinguish fact from fiction. Take this car, for example. Can it drive autonomously or not?
The short answer is absolutely.
That was Shweta Shrivastava, Senior Product Lead for Driving Behavior at Waymo.
What you're looking at is the Waymo driver in action. Adapted for a variety of vehicle platforms, it is the most advanced, fully autonomous driving technology in the world today.
What you notice pretty quickly is that these aren't normal vehicles. Take this Jaguar I-Pace, for example. It's been equipped with an elegant array of sensors and software, which allows it to move through the city on its own.
That's correct. The Waymo driver is a combination of custom-designed hardware and software that is responsible for performing the entire act of driving.
That was James Philbin. He's an engineering lead on the perception team at Waymo. I asked him to break down the technology for us a bit more.
The Waymo driver handles the task of driving in 3 basic steps: sense, solve, and go. It's the way we describe the highly complex process of acquiring information, processing it, and moving through the world safely.
So, what goes into all that sensing?
The sensors that the Waymo driver uses are incredibly powerful, using a combination of LiDAR, cameras, and radar. It can see up to 3 football fields in any direction and can detect sirens from emergency vehicles, which allows the Waymo driver to visualize the world around it in milliseconds to a high degree of accuracy.
Okay, sense makes sense. But what do you do with all that data?
Good question. The system calculates the predicted future behavior for each relevant agent in the scene. Then, with a strong foundation derived from artificial intelligence and machine learning algorithms, the Waymo driver crunches all that data and calculates a safe route, while responding in real time to the evolving traffic environment.
If I understand correctly, this means the Waymo driver continues to learn as it goes, is trained and tested on scenarios that it's never seen before, and can differentiate safe and comfortable driving behaviors from hazardous and uncomfortable ones.
Yes, well done.
Why, thank you. The final step in the sense, solve, go methodology is perhaps the most straightforward. Go.
Once the Waymo driver has determined the path to take, our advanced motion control systems allow for smooth acceleration and braking on hilly streets, or managing bumper-to-bumper traffic with safe and natural driving movements.
So it's really here, right now in cities. Not smoke and mirrors, but true autonomous driving technology. Waymo is taking what was once futuristic sci-fi and making it non-fiction. And like all great technology, all that number crunching, all that data just fades into the background. And you realize the dream of riding in a fully autonomous vehicle to your favorite dinner spot isn't just a vision of the future. It's actually happening right now.
So that, the intro video, let me just see if I can change my share again. So I didn't have it plugged in.
Staccato violin indicates witty dialogue.
Oh, really? So, yeah, this is, notice that it looked like that lady might have been expecting, you know, they're showing like, it's a safe car, you know, you can, you know, rely on it,
Save it all the hallmark.
But never see that unless you're positive.
yeah. Might have been, I don't know.
She's not in the room.
Yeah.
Yeah. Yeah, well, my apologies. But yeah, so, that's the intro and, it's incredible technology with incredible sensors. And I mean, fortunately, they do, you know, the introduction or
Throughout this
they,
experience,
they explain it very well, better than I can in their own videos. And there's a good number of videos here that explain what's going on. This one is I wanted to show you this one from a head of design. It's supposed to have an offset.
throughout this experience, we've been focused on building the Waymo driver, which is how we refer to our self-driving technology. There are two pieces to the Waymo driver: hardware and software. On the hardware side, we have a sensor suite that includes LiDAR, cameras, radar, and a powerful AI compute platform. Combined, these sensors give our vehicles a 360-degree view of the world over 300 meters away. On the software side, the brain of our self-driving vehicles, we take all of the information our sensors collect to answer 4 key questions. Where am I? What's around me? What will happen next? And what should I do? Together, our hardware and software work in concert to paint a complete picture of the world around the car. Throughout this experience, we've been focused on building the Waymo driver, which is
That's a little clip I took from their video just to show you the kind of the outline of the, I call it system intro. And here's the sensors. Actually, this is the web page. So here you can see there's a nice video going on of the LiDAR is giving. So this is what the LiDAR is giving the system.
So, I have a quick question.
Yeah.
When it was showing that, the very first video you showed, when it came to an intersection, I just sort of assumed that it would highlight the stop sign, like the sensor would show that it recognized this is a stop sign intersection. Like, how did it know?
Yeah,
It didn't have any sort of like recognition of it. Does it just know these streets?
Well,
Right.
okay, that's another, well, I'll get into that a little bit further later, but essentially the one of the assumptions here, or one of the prerequisites is that the city is mapped very
Okay.
accurately, and that's what this point here is, mapping out every intersection, sign and signal before they operate in a new area. That's why it takes time to operate in a new area, to set up operation. So it's not as simple as relying on GPS or cameras for everything. They need to map it, and it's a significant effort. Yes?
Sometimes, if the intersection isn't working, there'll be a blinking red light. That will be an unexpected event. So I
Yeah,
wonder
now
how
that
it recognizes that.
Yeah, they will recognize things like that because they they go through an extreme number of tests and simulation. They do simulation, testing, and then real world road driving. But there's a lot goes on in simulation and then in testing on a closed area and closed course type of thing with like a little intersection, things like a place where they can test safely and work out any kinks like that.
Do the cars also add a little map as they go?
No, actually, I'm not sure about that, but they do collect information. But like, if you remember years ago, there were these Google cars driving around and collecting, like taking
Street view.
yeah, sort of capturing information that goes into this giant database. And I'll show you that database has been open to the public. A certain version of it at least called the open data set. And it's like a huge amount of collected data from real world traffic interactions and with all these sensors. So it's sensor data, LiDAR, maybe radar, visual, and maybe radar too. But all that information is used in training. And that's all been collected from real city driving. Maybe by a human was driving it at the time, collecting data. And, but maybe even the automated one can collect data too. I'm not 100% sure. Let's go back to what I was. So yeah, here are the different sensors. You can see what happened, or it's not on the screen I'm on. Not updating or something? Did I lose connection? Oh, yeah, I lost connection to the Zoom workplace. This happened earlier when I first got in. I'm not sure why. Something with the Wi-Fi.
Oh, yeah, you disappeared.
It's like maybe the Wi-Fi is a little weak or something. Yeah, it's making me re-log into the Wi-Fi. Let's go ahead and do that. Back. Launch. I'm not sure why that's happening. Sure. So. So here, yeah, this what the LiDAR looks like, and then the cameras. You'll notice all these bounding boxes around cars, objects, and yeah, I don't see it around the signs, but if this is around all the moving objects, this is using models, object detection models, so they can detect where what the objects are and bring them into the system. And then radar looks like this. It's yet another overlapping sensor to that is very good under different weather conditions because it can see through fog and rain and snow very easily because of the nature of radar, and it can detect movement. It's used in combination. And this is the compute, it's underneath the trunk now, so you actually have room to put stuff in there. And yeah, this webpage is, this tells you a little bit about each one. I mean, basically what you pretty much, people here are familiar with what LiDAR does. And cameras, 360-degree view, and then radar is millimeter wave frequencies. Distance and speed are very effective, and it's effective in all these different weather environments. And then the CPU and GPUs are pretty serious power, can handle all that. So the software is a big factor. And of course, I don't have a lot of info about the software, but there is some hint of what kind of things it can do. So let's go to the next one, which is, so that was sensors. This is now the hardware.
Here you can see the breakdown of our custom-built hardware that makes up the 5th generation Waymo driver: LiDAR, cameras, and radar, as well as compute. Each of them is more powerful than the previous generation and equipped with enhanced capabilities. First, let's look at our new family of LiDAR, which has an even higher resolution across a wider range. As one of the Waymo driver's most powerful sensors, our LiDAR paints a picture of its surroundings in great detail. It sees the world in 3D and can see in the dark of night without any illumination. Our 360 LiDAR, which is located in our dome, can see up to 300 meters away and provides a bird's eye view of the cars, cyclists, and pedestrians surrounding the vehicle. At the same time, our latest perimeter LiDARs, placed at 4 points around the vehicle, offer unparalleled coverage with a wide field of view to detect objects close to the vehicle. Our new vision system, including 29 cameras, provides our Waymo driver with higher resolution images and greater perspective. Our cameras also have overlapping field of view directly around our vehicle. We've assembled them with cleaning systems and heaters for the best performance in any weather condition. Our new long-range cameras and 360 vision system now see much farther than before, allowing us to identify important details like stop signs greater than 500 meters away. In addition, our new perimeter vision system works in conjunction with our perimeter LiDARs to give the Waymo driver another perspective of objects close to the vehicle. Our new peripheral vision system helps us reduce blind spots caused by parked cars or large vehicles. These new cameras enable us to peek around objects, such as a truck driving in front of us, to see what might be there and to make a decision about what to do. Together, these various types of cameras allow us to make decisions earlier and faster with even more information than we've ever had before. And lastly, our radar. Waymo's new state-of-the-art high-resolution imaging radar, located in 6 places around the vehicle, tracks both static and moving objects, can see small objects at greater distances, and distinguish between closely spaced objects. Radar complements LiDAR and cameras with its unique capabilities in weather conditions such as rain, fog, and snow. Now, let's take a look at how these sensors are applied on the eyepiece. On the loop, we have a combination of our 360 LiDAR, 360 cameras, long-range cameras, and 2 radars. On the front, we have perimeter LiDAR and cameras. On both sides of the vehicle, there is a combination of radar, perimeter LiDAR and cameras, and peripheral cameras. And on the rear side of the vehicle, we also have perimeter LiDAR and cameras, peripheral cameras, and radars. With this understanding of our sensors,
Okay, that's a section I wanted to share there. And from the about the sensors and how about the hardware. And Yeah, and so that was generation 5. We're now on generation, that was design of generation 5 from a few years ago. Now 6 is out. And so the 6th one has overlapping fields of view up to 500 meters away, day and night, all range of weather conditions. It's reduced now to 13 cameras, 4 LiDAR, and 6 radar, an array of audio receivers. So it's gone down, and the reason is they didn't need to as many as 21, like it said before, because they've improved their software.
It was like a month or two ago, there was an HDRC thing, and someone had taken the robot with some LiDAR and went down the sidewalk, and it imaged both houses on both sides of the street.
Oh, that was Marco, yeah.
Yeah, so, I mean, this is a commercial thing that the hobbyist bought, you know. it's
Yeah,
crazy.
you can get a dome LiDAR. That was like $500 at
Okay,
least,
wow.
or 800. It was $800. It was expensive, but you can get a dome-based 3-dimensional LiDAR. That might be really cool for one of us to get someday. Well, he already has it. Marco has it on his. That was on like a was it a Mars rover? Yeah.
Yeah, it's amazing, the resolution.
Oh yeah, you have them.
Yeah,
Kind of.
yeah.
You got a spot for it?
Right, that's true. You can. So yeah, the generation 6 is out, and that is even better. And with fewer, they don't need as many cameras, which is kind of a cool thing. So just to mention, it's currently available in San Francisco, Phoenix, and Los Angeles now in the West Side. Coming soon to Austin, Atlanta, and then later Miami. So it's in a limited area in Los Angeles, just the West Side to like Hollywood, West Hollywood, and Santa Monica type area. So now, without further ado, you've seen kind of the basics. So now I'd like to share with you my story or my actual experience in the car with some family members. So here we go.
Ready?
Oh, I pressed it back here.
Oh, you have it.
Whoa!
Just give us 1 minute to cover
Yeah.
a few
You
riding
hold,
tips.
Okay.
This experience may feel futuristic,
Yeah.
but you need to buckle up. So keep your seatbelt fastened, please.
Oh, I'm sorry. I wanted
If you're trapped,
wanted you to hear.
Yeah.
I amplified this this voice. The car's voice gives a description of sort of the introduction. So listen, see if you can hear it. Let me make sure my volume
Can
is
you
up.
turn your camera on?
What's that?
Can you turn your camera on? I'll highlight you.
Oh, the voice is on here.
Oh, yeah, but for the recording.
Oh, you want me?
I'm gonna see your handsome face.
Yeah.
Oh.
This HR moment brought to you by Brian.
but you need to buckle up. Experience may feel futuristic,
Yeah.
but you need to buckle up. So keep your seatbelt fastened, please. If you're traveling with little ones or expecting, please see the seatback card for more information. Okay. We'll do all the driving, so please don't touch the steering wheel or pedals during your ride.
Do we do the pedals move?
Secure your cameras, check on riders, improve our products, and more. But our microphones are only on when you're connected to rider support. So sing your heart out. We can't hear you.
Okay.
You can also use the app or passenger screen to speak to a rider support.
I can't tell if the pedal's moving or not.
I could tell you.
Please keep your seatbelt fastened and remain in the car unless there's an urgent need to exit. Rider support will connect with you and provide assistance.
Ooh, it's turning yellow.
And thank you for riding with us.
Okay.
All right.
Here we are driving in San Francisco from Fort Mason to Embarcadero BART. It's it just went up to 21 minutes due to traffic. Ooh, someone's backing up to go into a space. The car stopped and is letting the guy go. I'll have you know the accident rate is quite low on these, but we're hoping it stays that way.
Okay, someone's walking.
Oh, we got pedestrians crossing. Oh, and he's pretty assertive. Bus is going by. Okay, we're proceeding. He's got his right turn signal on.
Is there a way to do like walks? Like
Oh, we got a red light.
on your phone, right? Top. Yeah, it just has random.
All right, we're at a red light. Here's what the map looks like. It's showing all the cars going by. Here comes a pedestrian. Does it show the pedestrian? Yep, it's showing little pedestrians there. See the little blue people walking? Those are actually real people.
Oh, yeah, we can see it right here.
And the cars going by are pretty accurate. Like you can see, okay, there that car turned. Yeah, you can see the cars being tracked pretty darn accurately. Here comes another car. And there's the blue.
Or those like
3 cars, 4 cars, bunch of cars.
Probably, yeah. Well, it's even got. It even knows that one's like. Why is that one red?
All right, we got a green light going. Oh, he wants to get over. Oh yeah, you can see the.
You can see where it's gonna go. It's pretty cool.
Oh, what is he doing? Oh, he wants to get in the right lane.
It is aggressive, kind of like
Assertive.
assertive.
Yeah, it's not. You know, you can't drive this city and not be a little bit assertive.
What happened? Oh, it dropped again.
Oh,
Unable to establish. Why is that happening? Having to reconnect.
want to send me the video and I'll share it through my screen?
Yeah. While I'm reconnecting here, or actually, I'm not connected, so I can't share you to anything. Right?
Oh.
Let me just do that. It's, nobody. Oh, I have to go to.
Just a moment.
It is on my on YouTube, but I just have to log in again here. If it happens again, I'm gonna be.
Let me see if I can find it on YouTube.
Wonder if I'm unsubscribed.
67766. I'll be back in a second.
It's good to see Waymo using all those sensors because, like Tesla, on the other hand, is reducing. They're pulling sensors off their cars. They're saying, well,
Jim, I have it here.
2 lines, but why do we need all these sensors on our cars?
I'm logged in, so.
Oh, you
Yeah,
want-
right.
You want to continue it?
I can continue, and then if it drops again, you can take over.
Okay.
Yeah, you're right. Yeah, you know, it's,
So this is more
they-
advanced than the Tesla.
well, the thing is, Elon Musk, he wants to run things with just vision because he thinks humans only need vision, so why should a car? But I really I don't care about the look of a way. In fact, the Waymo team wants the car to look this way because then you know it's an autonomous car, you know. And
I
so
like the way it looks.
it looks fine, right? You know, it's
It looks cool.
yeah, and so there's nothing wrong with that. I don't know if that's part of why Musk wants, you know, he does. Yeah, I think he more or less wants things to work with vision only for philosophical reasons.
Yeah. Oh, he's. Look at that. It's just how I drive. You can see the.
You can see where it's gonna go. It's pretty cool.
Yeah.
Oh, what is he doing? Oh, he wants to get in the right lane.
It is aggressive, kind of like
Assertive.
assertive.
Yeah, it's not. You know, you can't drive this city and not be a little bit assertive. Yeah. Oh, he's. Look at that. It's just how I drive. get around the slow pokes. Oh, he went back.
Lane change.
Yeah, that was a little double lane change there. Oh, we missed the light. He's got taxi cab algorithm in there.
You think these guys like talk to each other?
They might. Ooh, yellow light. Ooh.
Okay.
Yeah, we stopped before the. We're like, oh, is this a legal place to stop?
I don't know. I don't think so.
Well, maybe it is, cause well,
if there's someone, there's someone taking a right now.
we're not blocking anybody though. We're like, there's a median strip there. Right? We're a little past the stop line though, aren't we? Yes. Well, just look at this. We'll have to examine this intersection later. But we're past one crosswalk and before another one. Okay, these are pedestrians going across. Let's see. Oh yeah, you can even see them like standing. Now they're going across. And it's very accurate. That's what's happening. Here comes a car and you can see the little blue cars. Situational awareness is quite good.
You can drag the screen around to the circle.
Oh.
So you can see behind. It shows all the cars like behind us.
Oh, behind you.
And in front of us. And it shows all the people.
Oh, you can see us. Yeah. Coming to another light. You mean you did this, went around to the back?
And you can see all the cars.
Yeah, you can see the cars coming up behind us. And then, oh, it switches to forward.
Yeah,
you can see these people moving even that are on the side. They're crossing. You can see them all.
Yeah.
Or they're about to cross. I don't know. Oh, here comes another one right at us. I love it. Two robots. And we're following him. And he's getting off. So there's another. That's what we look. That's what we look like.
Says no stopping.
See.
Oh, look, we went around. Oh, here's some pedestrians. So that's what we look. That's what we look
Right here, this is no stop.
like.
Says no stopping.
See.
Oh, look, we went around. Oh, here's some pedestrians. You can see there.
At an implied crosswalk, because every intersection in the car, safety
There and
cross.
there's no crosswalk, but well, implied crosswalk, I guess. Ooh, now we're.
Let's see what happens here.
There's a guy in the way, and he's not gonna go into oncoming traffic. So there's this car there. You can see that car is over, we'd have to go across the middle line to pass him.
I've seen it cross into opposing traffic before.
Oh, it's thinking about it.
He wants to go.
I think it should.
Yeah, I mean, a human would probably go.
There's a pile up behind us because this guy won't go around.
So we're waiting. We're waiting here because. Yeah, there's like, I don't know. Should we do support?
I'd wait a second.
Our team is okay.
So did they?
I think that the human just got called into the situation.
Yeah.
Yep.
Okay.
See, that's a human now.
Nice.
I think a human got called in, and
Impressive.
Well, let's see what happens.
The
other Waymo behind us did the same thing.
It's maybe.
Yeah, I think a human got called in and just said, "Oh yeah, I gotta go around." Here's another one at this intersection passing. They're everywhere. And it's a stop sign. Oh, I haven't seen a stop sign situation. That means you gotta wait until it's your turn. Seems to have done it quite well. What's that?
So far, only like one issue, and that
Yeah.
Everything else went pretty smooth.
And that's a difficult issue because, you know, you don't want to go across that midline unless somebody kind of approves it.
Well, apparently my dad's went into a random parking lot.
Oh, really?
Yeah.
Oh, you texted?
Their Waymo went into a random parking lot.
See, we're getting around.
See, this was like if you drove me onto a boat or something, and then and like the boat.
I don't think you would drive you onto a boat.
She's
that would be purposeful.
finding a spot to pull over. Oh, okay. Looks like this is it, right in front of the Oh. Please make sure it's clear before exiting.
This is them. Wait, oh no, it's not. I don't think it is.
All right. Thank you, Waymo. We are leaving.
We've never done it. We're impressed.
Yeah.
It was pretty good. Only one issue.
Pretty.
Cars also have radar, and the radars are transmitting a Doppler, which means how does it cancel out the other car's Doppler? You know, they might have to have two different frequencies or something like that.
Oh, you're saying there, interference from other radar, other radar sending out, and you're trying to receive.
Yeah, you're trying to receive back.
So you get spillage, what's kind of like spill.
It must be, so every car today has a radar on it. Their auto stop, the thing that beeps when you're gonna hit a car in front of you, that's all radar.
Yeah, that's radar.
I don't know how they do it, that's a good question.
That's a good question, yeah, frequency, phase, something, phase, so. Yeah, I mean, or different phase adjustments, yeah, I guess.
Oh, did you want the upward video?
No, you can leave it on.
Okay.
The bar closing.
That might also be why Tesla doesn't do that, right? Tesla's removed all those sensors so that it doesn't have to deal with the spillage.
Oh, maybe, yeah, I don't know their reasoning exactly.
Well, there is that. He's trying
to reduce it.
Whatever you do,
That cost and the AI training. Which.
Okay.
One sensor.
So here's the question.
So that was my experience. Now I want to show, what a recent gentleman in Arizona had.
Okay, why is this happening to me on a Monday?
Mike Johns started rolling as the Waymo he was in started going round and round last week, and he started going in circles with customer service.
Why is this thing going in a circle? I'm getting dizzy.
He says it was spinning like a teacup at Disney World in a Scottsdale parking lot with him trapped inside and unable to stop it.
It's circling around a parking lot. I got my seatbelt on. I can't get out the car. Has this been hacked? What's going on? I feel like I'm in the movies.
In a video that's now gone viral, he says the Waymo turned like a top at least 5 times before customer service was able to get it under control and headed to the airport where Johns caught a flight back to LA. All the while, someone or something talking to him and failing to ease his concerns.
I don't have an option to control the car.
Oh my
I'm really so sorry about this.
Well, can you stop this car?
Over. I am trying
My
to pull
goodness.
it over right now. Apologies.
Where's the empathy? Where's the you?
Yeah, I just wanted to show you that one.
I don't know if I would continue the ride after that. Like, thanks, no thanks.
Well, he was, oh, right, he was still not at where he, at his,
I know,
at the
but-
airport yet, right? He
Yeah.
had to continue. So, that was, you didn't hear it in my video, but my, nephew said, oh, your brother just texted me, they're in a parking lot. So it happened to our other car, we rented 2 Waymos, and they, went around the parking lot, just one, and were out, but apparently that is a thing. Yeah.
Is there always a human on standby?
Well, I think there's a whole team of people that are, you can hit a button and call for help. There's a button to say pull over too, which I'm not sure why, if it didn't work for that guy, but I didn't press mine, but there is a button like pull over now. And then.
Well, is that available from the back seat? Because he was in the back seat.
Yeah, well, I didn't see the back, I think both, the controls are in both places. The controls are in both places, because my nephew hit the start button back there. I think the screen is the same. And he was able to do all the viewing of that screen from the back seat. Some people don't get in the front seat, so you have to have the controls in the back seat. as well. But, if you hit the button, call customer service, you get all the microphones turn on and you can talk to them. And in this case, if the car is held up for a certain amount of time, and I saw this in another video from a reporter last year who took a ride and the car got stuck at a green light, it stopped. And it was like waiting there, and then the screen came on, we are getting you out of this situation. And that's, obviously a human was called in, it seemed very likely, a human was called in to mitigate, just like they do with those delivery sidewalk cars. Humans get called in for those. So that's my knowledge of, it might have, from anywhere in the world, right? It could be in India or, So, so that one. Now, here I have to add in a little bit of humor, then I guess it'll be probably the last thing I. What happened? Sorry. Oh, there's a couple more things actually. So my wife mentioned something about being stuck on a boat.
Destination override. New destination 1 Gregory Drive, Air Alon. Distance to destination 4,126 miles. Enjoy your ride.
What's happening? I'm sorry, what? Mr. Carr? Carr? Mr. Carr? Excuse me. Airlon is an island, so how are we, oh no. Stop, let me out. That's not good. Oh, no, excuse me, please. Please honk, No, please. Oh no, that's not good. Okay, Donald, stay calm.
Destination override.
You can watch the rest of that show, but I just made a short cut there, but he's taking a local drive in Palo Alto, and there's this brand new fleet of autonomous cars, and the director, the owner decides, oh, we need them in this island. And so without caring about who's currently riding them, he just redirects them all to go. That's the premise, anyway. It's absurd, but that's what humor is. And then, here's another good one, that's actually from our news. It died again. My Zoom died again. I can't believe this keeps happening. But I have a quick way to get back in. Visitor. Sign in. Where is it? 67764. I think I'm cursed as far as the Wi-Fi goes. It's like there's always a problem. All right.
Again, if anybody has show and tell, let me know.
You got me on the list?
All right, I'm back down. That's the third time.
Third time's the charm.
There. Wait. Why don't can't you just have the default to share with audio? I mean, to share with sound. Somebody, need to email somebody at Zoom. Okay, so they're disrupting. Okay, here we go. All right. So I'm going to say here, not the best choice.
Southern California is notorious for high-speed pursuits, but tonight authorities may have encountered a robbery suspect trying to flee in a Waymo self-driving car. Police say they responded to a call that a suspect had robbed the Ralph's grocery store on La Brea Avenue and 3rd Street. Multiple cruisers followed the Waymo once the suspect got in. As soon as police activated the emergency lights on their cruiser, the Waymo pulled itself over in Arlington Heights. And that's when police were able to arrest the suspect without issue.
Look close.
So my advice to people, do not use Waymo as a getaway car.
It's 2025, and you're still using the same cable network?
It's not gonna work well for you. They have a lot of safety mechanisms employed, and one of them is if lights come on from a cruiser, it pulls over, as it should. And emergency vehicles coming up behind you will also do that. So last thing we're about out of time. The last thing I'd mention is, there's a lot of safety stuff. I'll send out this short email with all these links, but they have different studies from even like December of 2024 that show the safety record being better than human drivers, et cetera, et cetera. And so that's something to show up or to read up on, which is a good sign. And then Waymo has a lot of research going on and papers that are published, and you can see that in their research web portal here. And then the other thing is the open data set, which is available really for anybody to use, and it's got quite incredible information in it. You can access it. I was going to show a picture about these are different sources of data where they have lots of video, as well as the LiDAR data. There was another, I'm kind of blanking on what it was. And 3D information, all sorts of, it's really quite impressive.
What are some of those challenges that, the problems that they still need to solve?
This is a good one. They have an open challenge where people can participate. They close for this year, but they may do it for next year. But for instance, the first place, I think these are, there's different types of contests. Like this is motion prediction challenge. So that's really important. They, and then sim agents. It's in semantic segmentation, occupancy flow, different, and there's some money involved here. But I was gonna mention in these notes here, these, as I mentioned before, these 4 concepts are kind of important. The mapping of every intersection has to be done, sign and signal, before deployment. And then this keeping an eye on everything all at once. So it has to crunch all that data, sensing data. And then this is a big one here, predicting before they happen. You have to look at these different objects coming in and then have motion estimation. What is that pedestrian as he's likely to do, or that bicycle as it's moving? You've got to predict where this object's going to be in the next 1 second, or at the millisecond level, maybe something like that. So you can determine when this person or this bicycle or this car is going to be at this position, and therefore you plot your position to be in a safe place. And that's what this is, planning for safest outcome. Anyway, I guess, and I think that's about it. So hopefully you can try it out in Los Angeles. It is here now. Here's the bit about an LA. It's limited to this just like I said, the west side. Forget where that is. There's a map in here somewhere. But it's open to everyone. It was on a preliminary like invite list, but now it's here. So yeah, this just sort of shows you.
Thank you, Waymo. You're the best.
Now it's available. And it was at the auto show, right? Yeah, here's the Phoenix, San Francisco. This one I know it shows the map. Oh. Weird, it was on the wrong link. Yeah. Here's the map. So I don't live anywhere near here, but sometimes I go up to LA. Maybe I'll try it if I get up there. Or next time I have an opportunity or a need to do something. But yeah, it's
downtown LA.
yeah, it goes. Yeah, it's pretty. It's gonna get bigger, obviously at some point. But yeah, right now it's DTLA, downtown. China, as far east as Chinatown, all the way to Santa Monica and the Hollywood Hills westward. All right, well, thank you.
Curious if it'll drive you over the fire show.
You know what? You've written up the perfect summary of your own talk. If you wouldn't mind just posting that on its own message or maybe.
Yeah, I was gonna
thing.
that
That'd be perfect.
email.
Yeah, I'm looking forward to going through it.
Yeah.
Very cool. Thank you.
And with that, we break for lunch.
Way. Here is just temporary object detection, transient object. But I've saved the map and I've made it non-updatable now, so it's like fixed. So what I did was I used publish point here, and I ran a script that would capture each point and orientation. And so I made a kind of a square. I did it 4 times, 5 times around this area to make a square. So now what I'm going to do is I'm going to tell it to follow those waveforms. And you have to hold as the did switch. So here we go. Okay, just comes back on. And it's going down that way first. It's going to try to using what's called MPI local planner. So it will it knows how to steer a acronym steering and reverse. So this it'll wait at each point it makes. So if you share the screen right now, but if you see it's going to get to this point to satisfactory close enough, and then it stops and waits. Well, I guess I don't have to wait very long, but. So it's trying to, the problem with acronyms is to get to that point, it takes a little bit of maneuver. There, okay, that's a waypoint. Now, move on to the next waypoint. Yeah, the problem takes a little effort. Like, have to adjust the sensitivity so that it says, so it thinks it's finished this waypoint. Yeah, you should be able to. Okay, it's going to the next waypoint. There. But there's a way to tell it. That's That might be, oh, I see, it's got kind of, it's gonna have a little offset from reality. Let's run it again. We're gonna have to quite round up. So we go for, or. I mean, you have this sort of shocking numbers to say, if you're within, sort of the 1 meter or something close to the intended destination, then, your organization is done. It's a little, they'll try to get close and start backing up like it. And so on through, right? That would first. Second point here, right there, it's now, and so the map is a little bit off. So we'll see what it does here. Oh, it gave up with that. It looks like it aborted.
Oh, don't give up, buddy. You're almost there.
LiDAR. Yeah. So I haven't installed geometry yet. So that's now that things are stable. I'm going to install geometry yet. Thanks to Justin for those magnets. I still haven't done that, but so then that's just an example of waypoint following. But I can also, of course, give it a manual place to go.
How does it know where it's at on the map? Does it recognize doors or anything?
Well, it's purely on the LiDAR, in this configuration. So after it maps with that LiDAR, you can see the map here. Then it's using the Monte Carlo. Inside ROS, it's using a Monte Carlo algorithm, which with the LiDAR data, the current LiDAR data is sort of compared with the map. It sees that and lots of random points are created that the robot might be in, like a little cloud. It's a particle filter, yeah. So that's just the underlying, but the top level understanding is it's using the map here and the current LiDAR input and reflections in it. It tries to match. But sometimes I can get off. Like right now, this purple line here is like the LiDAR is seeing. That looks like it's off. It's thinking that there's a wall to the left, but let's see if that will correct itself. So let me see if I tell it to go somewhere. Tell it to go down further. Now you can see it. It will go around them. Go around. Let's see. Yeah, well, it's plotting around. Yeah. I just did it now. Yeah, it's best also to have a fresh map because if you don't find the exact place where you started the robot the first time, then the map is offset and it has to correct itself. And it just wastes time for a demo. Right. See, now what's happening here is it's a little bit too close to the wall. It's caught in this buffer zone, so it aborted. And you can adjust that, like how big, this is called an inflation. You can adjust how big the inflation zone is. And what I had to do is reduce the inflation to be very, very small in order to get around my house. But if you give it a target out in the open, it'll be much easier for it. So like if let's try to make it go like through or Alan.
Ow.
It's hitting you?
Yeah, it's trying to drive over my foot. Don't worry, I was just kidding. It doesn't hurt. Okay. Oh. There we go. Problem solved.
How do we make payments other than cash or check? Because I can't find my checkbook. I have a $6.
You can do it through PayPal.
Okay, PayPal.
If you go to our website,
It's on there.
yeah,
Okay, I'll do that later.
it's under donations.
Good.
Yeah, it's under About Us. Donate to RSSC.
Yeah, I'm
You just have to follow the instructions, so. On the PayPal, at the very end, they'll ask you for your name. Just put, or a note, just put, Trish and.
Sounds good. It's a good meeting. A lot of fun.
Trying to go right here. So I'm gonna try to, okay, now things are aligned. All these little dots. The original map. Synchronized. But it's a view of its current data. That. And things go back. And here's the door, so I want to have it come into the classroom. Well, let's see what happens.
No. Oh.
Did it abort? Okay. And there. So what happens is if enough error, so that the system will abort trying to get there.
If you just have 3 reflectors, that's all you need. You can go any place.
Reflectors.
Yeah, on your car. You have taillights, reflectors. Yeah.
Able to get around.
In other words, one laser.
Oh, gotcha.
And just swinging around.
Mhm.
And you got 3 points in space.
Okay. That'd be a fun thing to try.
Actually, 4 points and you increase your precision.
Okay.
That's
right.
Yeah, it's simple stuff.
Oh, sure. Don't run over your dad. I see how it is.
Okay, well, yeah, I think it's a little harder to prove it's working with the patterns here like that. But they can't turn on a dime. Well, let's have it go in the. Still want it to go into the class. Let's go in the classroom, although there is something with it.
Actually, yeah, very tight situation, so it, you can't really block much of the door and expect it to go through. You know, it's like.
Almost there. Almost there. Kind of. Oh, there we go. Yay.
I like how they just have a list.
It's one of the harder
laser configurations and not just bing, bing, bing.
This sounds kind of like what they do with LiDAR in cars, right?
Yeah.
Just let some things spin around. Okay.
Trying to do this indoors.
Use the modulator.
Yeah.
Activation.
Mhm.
What is that? Single turn, as opposed to a slip steer or a skid steer or a differential.
Okay.
All right, well, thank you.
All right, Jim, thank you very much. That was very cool.
Turbo does the kind
All right, that was great presentation, Jim. Thank you very much. Next up is Alan.
Oh, okay.
That's behind the cone, you know,
All right, so this will be pretty quick. In my trip down memory lane, I was reminded of something I was doing in the early 2000s. The concept of a Beowolf cluster. You could string a whole bunch of cheap computers together with Ethernet and do something more powerful they can do as well. At this time, we're talking about 2 and 4 core processors. And one of the first things that I was wondering was, is there really a place for an ancient term like a Beowolf cluster in, you know, the mid 2020s? And so that got me looking and thinking about, well, if you wanted to do one, why would you do it? If you just wanted something to get some experience with Proxmox or Kubernetes, you could, you know, string together a handful of Raspberry Pis and then I came across an article on Serve the Home where they were reminding me that there are oodles of 1 liter PCs in various configurations that are just right for stringing together into a cluster. And then it turned from a question of why to a question of how. And so I started looking around, and there's 3 or 4 different kinds. They're all super small. You can buy a bunch of, you know, 10 i3 8100s for $400, which is about $50 each, which places you in Raspberry Pi territory, right? But a lot more performance. And then it got me thinking of how much processing power you could cram into a 1 liter box. So we're talking about boxes that are like this big, super small. And these guys at ETA Prime posted an article about the Think Center. Like, okay, well, the name's Think Center, that's cool too. They've got a space in them for with an adapter for a GPU. And so that got me digging in down the rabbit hole of, you could stick in a 6 gigabyte RTX 3050 in there to run deep learning workloads up to a point, to something like the RTX A2000 or the A2000 Ada, $600, $900, or the RTX 4000 Ada with 20 gigabytes of RAM. And there's someone, I have a whole category, tiny cluster now, because, you know, why not? You can buy a single slot cooler to cram this in. And it was a fun little thing. I haven't figured out a use case yet, but it's possible to build out a 1 liter PC with a 12 series i7 processor, up to 96 gigabytes of RAM, up to 2 terabytes of storage, starting at 600. You could cram in an $1,800 RTX that has about 1,000 teraops. So it's about 1/4 of an RTX 3050 in an 80 watt power envelope, with an aftermarket cooler to build something that runs super hot, but is also super tiny. So if you guys can think of any use cases for multi CPU cluster with 6 or 8 or 10 of these things stacked on top of each other, I think it would look really cool, but I haven't figured out a reason to pull the trigger on any of them yet. So
Wait, I think I missed it. How do you get the GPU into that tiny PC?
Yeah, so the think centers up till Gen 3 have a third-party slot, an adapter that'll support an 8x PCIe 4 adapter to plug in a short single slot GPU.
So it hangs off the back or something?
It fits inside.
No. Huh.
Yeah, I'm sorry, anywho, like, that's what, from the why would you do it at all to how much power can you cram into a 1 liter box? So far, my limit is an i7 12700T with an $1,800 graphics card, stuffed in with an aftermarket single slot cooler and 210 watt Lenovo power supply. So anywho, I don't think anything will come of it, but it was interesting to kind of see what that would look like if you had a need for a stack of super sexy 1 liter boxes with the name Think Center on it. Come on, who can ask that? To do something interesting in a Beowolf cluster. So I will let you know if anything becomes of it, but it was fun to go through Imagination Land for a minute to see what as a how without having the why in it. So yeah, that was it. That was one of my little sidebars this week. All right, thanks.
No, okay. Thank you, Alan. So Alan was the last one on the list. If there's no others, I think we're gonna call it a meeting.
Yeah.
That's all I had.
Meeting.
I saw a headline, Alan. It was, and I didn't read the article, but I think they were saying if you want to build a PC with the latest NVIDIA thing, it's gonna be like 20 grand or something. What the article said, yeah.
Well,
Way too high. I'll have to find it. I'm sorry.
yeah, the RTX 5090, which I'm gonna buy 4 of, are supposed to retail for $2,000 a piece, and that is not cheap by any stretch of the imagination. But its ability to run larger workloads on a single GPU and even faster in a 2-slot solution, the cooling solution alone is pretty amazing. And they're the only ones that are doing 2-slot right now. Everyone else is 2.5, 3.5 slot and super long because you're trying to dissipate 600 watts of
Oh, so they're doing,
They went big,
double,
yeah.
only double slot. I mean, the
Yeah.
NVIDIA is gonna be more efficient and cooler.
Yeah, and you've got the Jetson Nano Super, which has a slightly overclocked Ampere with an ARM coprocessor. And then they have Project Digits, which is they paired up with MediaTek to produce a little mini box for about $3 grand with 100 gigabytes of, I think it's shared memory. And then you can NV-link 2 of them together for 200 gigabytes of memory. That looks promising, right? So now you've got performance at every price point. And I'm not sure if I'll look at the Beowolf for more than the next day or so, but it was interesting to see, like, to get it started, and it's actually cheaper to buy a whole bunch of used i3s than to do new Raspberry Pis. To, if you had more money than sense, how much processing power could you push into a stack of with 2.5 gig Ethernet? And I thought of all of that, what use cases would that serve that, a single box can write in? So I don't have the why, but I have the how.
Yeah, I mean, if your furnace rate
Has 128 gig of RAM, so there's your use case right there, is you can run anything. Like, when you put 4 of them together, you've got a terabyte of RAM.
You do, but the workload needs to be distributed in a way that's latency resilient, right? So you still got 2.5 gig Ethernet, faster than 1 gig Ethernet, but you wouldn't necessarily split a deep learning model across those boxes.
But you could run a bunch of very good, more specialized models.
Right, yeah.
For your LangGraph.
Yeah. Yeah, so that might be it, as opposed to building out a Xeon or a Threadripper Pro with that, it would be interesting to crunch the numbers between the Weston 3050 and the $1,800 4000 to see now that with the revelation that you don't need an 80 billion parameter model to do performance stuff, it opens up a whole new series. Maybe I'll build one. Just, I mean, you can't really know until you get hands on the hardware. But yeah, anyways, I was reliving my old days of going in Excel and like, okay, I could buy these on eBay and without having a use case for it, but it sounded cool. But now instead of having a stack of boxes, it's a stack of boxes.
So it's a solution in search of a problem.
Exactly. Those are the best kind, right? Because those are the very best
kind.
It's also discounted, so that's a lot.
It's discounted because, I mean, off eBay, you mean?
Yeah, you can spend as much or as little as you want. So I can find a stack of 10 i3s for, I think it was $400 or $600.
i3,
$40 a piece, right? So that's cheaper than a pie.
Oh,
right?
They're small boards. These are.
Yeah, here, let me go, we'll go back to the, so here's the lot of 9 i3 8100s. You get 9 of them for $400.
I'm sorry, tiny PCs.
Yeah, yeah.
Okay. But that's the whole cluster,
That's a cluster. You add in a switch, some Ethernet cables and paper power.
okay, but this is not with the GPU. This is just the.
No, that's just the boxes, yeah. But you can spend $40 for the adapter and $200 for an RTX 3050, which would give you 6 gigabytes of VRAM in these boxes.
Oh, I see. So you have a concept of an inexpensive cluster for AI.
Which was the only way to do heavy lifting before, but now, you know, you can get a 96 core 128 thread Threadripper Pro, and it's not cheap. But you want to run the numbers again. If you're trying to solve a problem, you look for the lowest cost option. It's the problem that I'm sticking on. I don't know what problem to solve. But running smaller language models in parallel, because those parallel, they don't make you running on the same device. Maybe that's it.
Yeah, because you, like you said, you can't share the GPUs across the internet.
Yeah. So, from $200 for 6 gigabytes, $600 for 12 gigabytes, $900 for 16 gigabytes, and $1,800 for 20 gigabytes. You've got available all different price points. You have a GPU in that thing. It's literally.
Right.
When did the 5090s go on sale?
January 25th or 30th. Let me check my calendar. I wrote it down.
Right.
I know I'm not gonna be able
Do
to.
you have a little chain, you take off one chain link per day and then the day?
Oh, yeah.
It's
The countdown.
Countdown, yeah.
Oh, kid countdown.
I thought it was crazy, this is 70 is equivalent to a 49.
Well, it is, but it's not. When you enable DLSS 4 and the frame thing, equivalent performance with modern AI tricks. So it depends on your perspective. I think it's comparable, but if you're a purist, then.
Sure, if you're curious, but I mean, for $500.
January 30th.
Oh, so it's cheap. In other words, like 50, 70.
Doorway there, see the doorway there?
Almost as good
Or
as
see
the
the
49.
door
If you're
there,
running
then it goes
three
wider
AI
from there,
frames
then it
per
goes,
real
go
frame,
through. That's
then
one
you
sensor.
typically are the same as 49. Some games are slightly over, and a lot of them are cheap.
For the MPA or.
For the DLSS,
DLSS.
when it triples your frame.
Yeah.
So, well, take it twice, but yeah, you render one, and then it builds 3. Whereas the 4090, you can only render one and build another. So that's the reason it's close, but even then, it's not real performance because your latency goes up. And then you also have the problem of frame generation adding its own artifacts, which is a huge issue.
So it'll know.
Like I've used it and it's just too distracting.
You're talking about the 4090 versus.
5070.
With the frame interpolation and
But
the.
the thing is.
Or even 5080, like the 5080 is probably gonna be pretty close to 4090. Like
Raw, but not as good as you really, not with that.
I mean, it's fine.
It has a frame
Some people
interpolation.
aren't sensitive to the AI frames. They don't notice it, they don't notice the artifact.
It's got artifacts.
It's artifacts and like.
Right. Okay, but for other AI applications, it's slower.
You know, AI is using this idea like that, is that if you'll approach from this angle, now you're gonna have
So there's no
Not
equivalent, it's
square
not that
with
equivalent.
Yeah,
Close
Justin's
to-
probably the one
let's say
that knows even more about this than I
3
do,
feet.
so it's nice to nerd out here, man. I don't know if you're anywhere near as excited as me, but yeah, the two slot, I was betting people lunch that if they're admitting to two slot, then they're admitting they can't keep it full without an AIO. I was certain that's how they were doing, if the rumors were true. Like,
I mean,
when he showed off.
one slot, my 4090, I can run it at basically one slot, but yeah, it's touching water for it. So.
Yeah, so yeah, the thing, that's the part that caught me totally off guard. So now I don't have to do risers anymore. I can just.
Yes, I mean, as long as you get the founder's edition, from the looks of it, everything else is gonna be
It's
free.
just chunky, right?
Yeah, they're basically gonna be using 4090 coolers again.
I thought, so what, the 3090 I have is only. It takes up two slot area.
Well, it takes up more than two.
Wave.
Unless you have an all-in-one.
So.
Like 4090 is.
You mean the width,
Like 3090 is 3.5.
yeah. I don't even know, yeah, I guess I don't know, because the phone is not. only one spot.
Yeah, they're chunky.
Yeah.
Yeah. I see, you're saying it's down to two for the.
It's like an actual two, not like 2.5.
Heat up your whole thing.
Yeah, but there's no venting to the outside.
Yeah, well.
So you gotta have exhaust fans to pull it through. But because they're all through and through, I'm banking on, if you just set them side by side, as long as you have enough airflow.
Oh, you're, so does it push your air at the back, or is it usually air? In your case?
The card's this way,
Barely.
it's pushing up. Or you can stand, but it's one or the other, but yeah, they're both through and through, and the card and the both
Something
right.
is a big tunnel like this, and you left it out the back.
No, the server ones are like that, the consumer cards have been, yeah.
My gaming one is, well, it's in the side of it, like, it's like this, and then fans are on the bottom and the top, like 9 fans blowing, like.
Yeah, well, the airflow is gonna be
One
important.
blows in and the other one, it's a single direction.
Funny how the tower, they had a number of slots based on the cards they think you would need, and now you need the same number of slots for the one card.
That's like, the gaming laptop, the gaming, PC I got, it only has one slot there. Well, I figured that's it.
4 slots for graphics.
It's like,
It's heavy.
they're bigger than the 3090.
I don't know, but all I know is like, it's huge, it looks good.
Yeah.
Huge.
So if something gets. So if I have a 13 minute one,